Yeah. So as I said, this session will be mostly on the techniques and methods what we have seen in the earlier session. Okay, so we will see all the practical things on certain theory and also formulas here. Okay, so once we knew about the formulas and why do you want to do that and all, and we will move on to the notebook, the code in the second half of this session to deal with the code. Okay, so before that, someone asked like what is the difference between bias and variance. Okay, it's kind of tricky in machine learning context because biased means what we basically tell is it's biased towards a certain category or certain data. Okay, but in machine learning terms it's kind of different. It actually gives us an inverse meaning. Okay, so first thing, let's have a data. Let's say we have a data like this. Okay, so we have weight and height. Okay, so based on the weight we are finding height. Okay, so you can see data trends kind of follows like this, but after a certain time only the weight will keep increasing, height will not increase, because 6 feet or some 6.5 is average, right? After that people will not have an increase in height, mostly will have an increase in weight only. Okay, so in this case let's build a model. Let's say we are building a model to predict it. Okay, so if it is like this, we are trying to let's convert them into training data and testing data. So this would be the optimal curve to map out the function. But let's say here we have red data, which is here we have blue data, which is training data, and green data, which is testing data. Okay, so once we have uh, training data and testing data, the blue is training and the green is testing data. So now let's try to map it. So here we are trying to map it with a linear function. A linear function is just a single line. Okay, but this line is not flexible, okay, or not complex enough to map out the function. You can see a straight line kind of approximates the data. It kind of tries to align itself where it can equally consider all the data points. Okay, so in this case what will happen is we call it as high bias. Okay, high bias in the sense the inability of the machine learning, okay, to capture the true relationship. Okay, so it cannot capture the true relationship. So if the bias is low, then we can tell actually the model is actually capture the relationship. If the bias is high, then it has not actually captured the relationship. Okay, then this is a high bias model. Okay, this is a high bias. Okay, and you can see the straight line can't be curved like true relationship. It can be relatively high, large amount of bias. Okay, the inability of a machine learning model to capture the true relationship, that's the bias. Okay, so high means cannot capture, low means can capture. That's the thing. And second thing is, let's put up another model like this squiggly line. Okay, this squiggly line kind of closely approximate, like finely approximates the training data very clearly. And here you can tell very little bias because data is very well mapped out. Okay, data is like kind of very well fit to the training data. But here what we can see is, now for training data this is high bias, this is low bias. Okay, so the straight line is high bias and the squiggly line is low bias. But when it comes to testing data, so here if you put testing data, again this straight line would give a similar result as it has got with the training data. So training data and testing data, there will not be much difference in the error because it has approximated considering all the data points. But here if you see, this would completely give a opposite data, because here it is a very hard curve. It cannot able to generalize for some new data. In this case what will happen is, this we call it as a variance. Okay, so variance is in machine learning lingo the difference in fits between data set is called variance. Okay, so there is a difference in fit, so that so in here it is perfect fit. Okay, but here it is no fit at all for the training data, so here we call it as a high variance. Okay, but here this is low variance, this is a high variance. So this is underfitting. For underfitting it is always high bias, low variance. For overfitting, low bias and high variance. Okay, but for just right is optimal amount of bias and variance. Okay, so you can see this high bias means underfitting. Okay, low and high variance means overfitting. So remember this is underfitting. Okay, high bias. this is overfitting, high variance. Okay, so our model has, so how our model has to be, our model has to be in a optimal, it has to be relatively low bias and low variance, so that it can able to map the function, and also it generalizes for the new data as well. So that is why we are going for this high bias and variance method. Okay, right. And let's move on to the data wrangling part. Okay, uh, data wrangling and exploratory data analysis. Uh, First part is about data transformation, and second part is about understanding the data. So it involves a lot of steps, and it has a lot of tools included as well. So mainly it is NumPy. Okay, NumPy for matrix multiplication and data manipulation. Pandas two for again for data manipulation, tabular data manipulation. Okay, and third is visualization tools like Matplotlib. Matplotlib, we can use Seaborn or Plotly. So we can use these three things to do the data wrangling and exploratory data analysis part. Okay, so first let's come to data wrangling. Okay, so why do we need to do data analysis? Since data is everywhere, we can do data analysis, data science to help us answer certain questions. Okay, so what data analysis helps us to discover useful information, and it can use to answer a question, and it can be also used to predict the future or unknown. Okay, so let's take up a data like this, UCA data. So we have UCA repository, we have Kaggle data. We are taking this automobile data set. Okay, automobile data set is a set of used cars. Okay, you take the used car data set and you wanted to predict the price. Okay, based upon the fuel economy, number of seats, the year manufactured, the engine type, the model, the brand. Using everything, you have to find the car pricing. So that is our idea. Okay, so estimate the used car price. Okay, so certain questions we can ask. Okay, so these are all the questions that needs to be answered. Okay, let's say there's a guy called Tom. So how we can help Tom to determine the best price for his car? Okay, so that is the first thing. The second thing is there data on the data on the price of other cars and their characteristics? Okay, the comparison between them. And third is what features of the car affect the price? Okay, something like price is related to certain brand or the engine type. Color is okay, red color car, it can be an Maruti 800 or it can be an Audi, both are red, is right. So sometimes color might affect, sometimes brand might affect, sometimes horsepower might affect. So we want to find which feature affects the output. And finally, asking the right question in terms of data that is there. So we have data. So we have a CSV files. We taking the CSV files. Okay. So when you import the data itself, it will also have a data file which is CSV file. Okay. It has rows and columns. Rows is independent entries and columns is features. And columns will have both the features, the inputs, and the labels, the outputs. The columns will have both the input and output. It is for us to choose what should be our output and what should be our input. Okay. That the feature selections happens like that. And we also have description file. This description file will give us the initial few details about the data. Okay, so that is the description file. So the choice of libraries, we would be using pandas for data manipulation, tabular data manipulation, NumPy for arrays and matrices, SciPy for doing some mathematical analysis like integral calculus. Visualization, Matplot and Seaborn. Seaborn are much more can do rich visualization. And finally, algorithmic libraries like scikit-learn, stats mods. Okay, so we will see them one by one. Okay, so the first thing would be importing the data. Okay, the process of loading and reading data. Let's say data can be of any type. It can be of CSV, Excel, text data, JSON data. Can be from a REST API. Can be from a database. It can be from a file system. It can be from a Hadoop file system, videos, audios, anything. Okay, because I have worked on every sector. That's why I'm keep on telling the numbers. Fine. So the format would be, most of the format would be CSV or JSON. Okay, and you'd be giving some file path and things to import the data. Okay, so we are importing data using pandas. Okay, so once we import the data using pandas, it becomes a pandas data frame. So data frame is a single thing that you need to keep in your mind. Okay, rest of the things you can forget it, no problem. Data frame, so you can apply a lot of functions on data frame to get some results that we will see in code. Okay, pandas data frame is there, and we can get basic insights about the data type. You have to find what all the data types, whether it is an integer column or it is a categorical column or it is a date column. If it is a date column, then you can apply like at what date has occurred or what month it has occurred. If there is sales, at which month there are maximum sales occurring. Let's say it's a festival season or Pongal or Diwali or some other festal season. So different columns, data types, float, integer, boolean, string, and date type. Everything has different things. Okay, and we can get some basic description and information about the data. So that is one thing. Okay, and second thing, accessing the data. So accessing data can be simple as a file. You can use a URL to import the data, or it can be database where you run queries and extract the data. Okay, running queries and extract the data, you'll be using a function like this. Connect to the database, run a query, select star from table, and you do the fetch all. Okay, so this not be doing, but again you can do this. Fine. So the first step is you have imported the data, okay, from the CSV file or else a database, and you have created a data frame. So the first thing, importing the file into a pandas data frame is the first step. Second step is pre-processing. Okay, so pre-processing is kind of data cleaning and wrangling. So you can see the objective: identify and handle missing values. Okay, and data formatting. Okay, data normalization, centering and scaling, they also call it data standardization. There are different techniques for it. Data binning. Okay, you can convert categorical to continuous, you can convert continuous to categorical. Okay, and again turning categorical to numeric variables, and binning used to convert continuous to categorical. Okay, so let's say we have age group from uh, 1 to 50, then we wanted to convert them into child, teen, adult, elder, and more. Okay, then what you can do, it is a, even though the age is a continuous variable, it gets a number like 15, 20, 40 and all, we can convert them into categorical. As like if it falls within the range of 1 to 10, then we can consider as a child, which is class 1, which is 1. Okay, and if it is between 10 to 11 to 20, then it is a teen, then you can put a number up to 2. Okay, that way you can convert continuous to categorical, and also can categorical to continuous, you can do that. Okay, and first thing is dealing with missing values. We will come there. Okay, dealing with missing values, there are a lot of methods how you can deal with that. Okay, the first thing is simply drop the entry. That is what being done most of the times. But if your data set itself is limited and you have dropped most of the data and you feel like you are losing a lot of information in that case, what you can do is you can go for data imputation. Okay, data imputation, there are a lot of techniques, you will see them one by one. Okay, first thing, for dropping, you can use drop any, it would right away remove. For data imputation, you can go for, let's say it is a continuous variable, then you can go for mean. Okay, or median. Okay, it should be based upon the data what we are dealing with. Sometime mean would work, sometime median only would work. Okay, and let's say if it is a categorical variable, then you will take the then if it is a category variable, then if there are 100 data points and 10 are missing, you have 90. Okay, and out of 90, then 50 is men and 40 is women, just think of like that. Then you can see the distribution. So here 50 is there, here 40 is there, and the remaining 10 is unlabeled. In that case, what you do is you randomly fill the data, those 10 data with you cannot go for 5 out of 5, because the distribution of men is more than the women in the collected data. Okay, in that case you can go for 6 men and 4 women, some random labeling for the that 10 data. Okay, that way the distribution will not get affected. Okay, so in that case you can input the data. So if it is regression, it's some type of imputation. If it is classification, then it is some type of imputation. And data formatting, why do you want to do data formatting? I'm just telling you the theory quickly, 10-15 minutes, and if you want the code, you will know clearly what I'm telling. Okay, so data are collected from different sources. It might be a JSON or Excel or whatever it is. Then you non-format data, it would be confusing, hard to aggregate, hard to compare. Okay, and you can see, just for an example, city, it is New York, new space York, New York, new dot York, new n dot y. Okay, so all these things are same data, which resembles, which tells about a city, but it is not in a standard format. So that if you do integer encoding, this will be 1, this will be 2, this will be 3, and this will be 4. Okay, everyone will have different encoding format. And formatted data is more clear and easy to aggregate and easy to compare, and every similar value will have the same number. It is a precisely converted data, so that you will have a better you will have a clean data. Okay, and so data formatting, applied calculation upon entire column on or incorrect data types. So why do we need to do data formatting? First thing is data normalization. Okay, so why do you want to do data normalization? Okay, so okay, see 3 columns: length, width, and height. Okay, So here, scale in the sense for length, it is about 150 to 250. The scale is from within this range. Width is within this range and height is between this range. Okay. So if you see the impact of this variable, so especially if you are using, see, this is not for this data impact, large, small thing will not affect models like decision trees and random forest, because those are rule based models. But for distance based model, okay, distance based model is a regression, uses distance between predicted and categorical to find the error cost function. Okay, and k nearest neighbor, okay, they use distance to do the classification. In that type, these values which are higher in order will affect the model. So in that case, what we do is we do the normalization, so that we divide the entire number with the maximum number, so that every value falls within the range of 0 to 1. Okay, so this is not normalized. Okay, so age and income are in different range. Age is 20, 30, 40, and income is 10k, 20k, and 1k, and like that. So it will have more influence. Okay, hard to compare, and influence will have more impact. And if you do normalization, you can see both are divided by the maximum number. So let's say here the maximum number is 10. Okay, maximum number is 100. Divide by 100 every column. It is zero point 0.2, zero point 0.3, and 0.4. And here the maximum, let's say it's 1 lakh. You divide everything by 1 lakh, then you would get 1, and here you would get a 0.2, and here you would get 0.5, like that. Okay, so normalize is similar value range, so every value will have equal influence. But this is not same for all the models. It's different for different models based on how the model internal mechanism is. Okay, so for normalizing we have different techniques. Okay, the first thing is simple feature scaling. Take the maximum value, divide everything with the maximum value. Okay, and min max scaling. Min max scaling is take the maximum number and subtract with the minimum number, so that you will get a center value. Use the center value to do the subtract with it and divide by the value. Okay, and third one is z score. You take the standard deviation and mean, and you do this z score is mostly about technique called standardization. Standardization is mostly tries to mean center the data. Okay, so you take a mean, and it would try to group all the data closer to the mean. That is what standardization does. And you can see the range is mostly between -3 to plus 3. But normalization, it tries to bring in the range from 0 to 1. It takes the maximum number and use the maximum number and divide.
Navneet sir, your voice is not audible. Navneet sir.
Okay, is it okay now?
Yes, yes, yes.
Yeah, fine. Okay, there's small problem with the mic. Okay, fine. So yeah, normalization, I think will certainly recap. So you know this, why we are doing normalization. There are certain type of normalization. Simple feature scaling and min-max scaling always converts the numbers to 0 to 1 range. Okay, and z score is a standardization technique. It tries to mean center the data. Okay, you calculate the mean of the data, you take the standard deviation, and you calculate the new value out of it, so that all the value will be in the same range of same impact. And the next is binning. So binning is used to convert the continuous variable to categorical variable. Okay, so let's say you have a, salary range, but you don't need the entire range. Like someone would be getting 5k, 500 and 5500, 5800. So everything is kind of in similar manner. Like it's not you don't need to have a direct regression. Okay, in that case, what you can do is you can convert them into low, medium, and high. So whatever the salary falls between 5,000 to 12,000, you can call it as low, and you can within that range it is mid, and 39 to 45 is high. You can split them. So converting continuous variable to categorical variable is one of the feature engineering technique. Okay, and if you visualize it, then you would know the distribution, like how the data is distributed. Like again, distribution histogram also uses binning technique to get the frequency. Okay, that's the thing. And turning categorical variables into a quantitative variables, here is why needed is, you can see the problem statement. Most statistical models cannot take in object string as an input. Okay, in that case, what you can do is you can convert the categorical variables into quantitative variable, like we do one not encoding. Okay, so here one not encoding, so either if it is just two category, we can put gas as 0 and diesel as 1. But if you do like that, what will happen is 0 has no effect, right? So this uh, okay, so I've got a question. What is the difference between simple technique and min-max scaling? See, if you do simple scaling, it is always taking the maximum number, okay, and dividing it with the dividing the every number with it, okay. So the minimum number gets 0 and the maximum number gets 1, and within the range which get those ranges, okay. But if you do min-max scaling, it also gets the result, but it is it's considered the center value, okay, and it would try to divide based on that. But sometimes it also gives in the range of -5 to +5, okay, minus zero point 0.5 to plus 0.5, okay. So that way you can do min max scaling. If the data is very diverse, okay, you cannot always take the thing and do the process, okay. So if, like as he said, if x minimum is always 0, then the min max scaling will become the simple feature scaling. So if the minimum value is 0 and 0, then it's again x old value versus divided by the maximum value, okay. So if the minimum value is greater than that, then you can subtract it and you can do the plotting, okay. Yeah, so that's the thing. I think someone, Prashant, kind of gave the hint. So, uh, that's the difference, but both gives us the range between 0 to 1. And again, converting the quantitative variable to the one not encoded variable. So you cannot have like just zeros and ones. Of course, you can do integer encoding, but in case of more classes, you can do one not encoding, so that it will have like wherever there is a particular feature is present, in that place you will have 1 and rest of the places you will have 0. Okay, so that way you can do one not encoding. And for that you can use pandas.getDummies method. Okay, so you can do that. And other ways to handle missing data is simply delete the data, means substitution, regression imputation, and last observation carry forward. So missing data, list-wise deletion is you delete the entire row. Mean substitution is you substitute the mean value of for that particular missed cell. Regression imputation is you can use a separate model to impute the value as well. Let's say if two columns are correlated, okay, I'm just giving a simple, very simple example. You have a birth year, okay. Birth year is year, but you don't, but there are few missing value in the age column, okay. So what you can do is you can use the birth year to fill up the age column, okay. So it's simple.
Namit sir,
So hello.
sir, one question from audience, sir.
Yeah.
In chat box, what is the difference between simple tech versus min max? Both
I've already
like,
told it. Already told the answer.
okay.
I'm reading the question. I've opened the chat window. I'm just reading the question as well.
Okay.
Um, okay. So yeah, so we have regression imputation. So I'm just telling a simple example, like you can use the year to that, but it is not that simple. You can have correlated columns, height versus weight, and you will have other correlated feature. You can use a linear model to map out the imputed. You can impute the missed value as well. Okay. And last thing is last observation carry forward. So this is used if they are conducting any poll or else taking any survey, okay. If certain data are getting in the same city, like pin code or Coimbatore, then you can use the same Coimbatore for the same region, okay. Because if there is 1 2 3 is country, a state, a city is Coimbatore, and 3 4 is missed, and 7 8 9 is also Coimbatore, then you would know, okay, so they have taken a survey in a city Coimbatore, and there are certain missed column. In that case, you can go for last observation. Like what is the last observation? You can continue with the same for that imputing that particular cell. Okay. And data munging, they kind of confuse it with wrangling, but again, it tries to achieve the same thing. Munging is uh, transforming the data. Okay, transforming the data from unstructured format to original structured format. Okay, we will see that. Okay, but data preparation, what are all the techniques you have is um, data is data preparation. So first thing is missing value imputation, one not encoding, ordinal encoding, cardinal encoding, normalization, and transformation. So all these things comes under data transformation. Feature engineering. You can find correlation, okay, and you can create more features using augmentation, or else can do polynomial features. Okay, let's say you have simple features, then you can add up the polynomial things and you can get more features. And binning numerical features and combining values, that's where feature engineering comes in. Feature selection, again feature importance, so which features have more impact on the output, and again considering the variance and bias and reducing the dimension using PCA, then you can go for things. So these are all the steps involved in preparation. So in code we will execute all these steps one by one. Okay, so before coming to exploratory data analysis, I got a question from Prabhu Ram. While handling missing data through certain substitution method, which is not absolute data, will it affect the model? Again, yeah, it will affect the model. The imputed data will affect the model, but we should impute the data in a way it doesn't affect the distribution of the data. Okay, so once the distribution is not affected, as I said, if there is men and women, for out of 100 it's 60-40, and now we have out of men, like we have only 90 data. From that we have like 50-40, and when we are trying to impute the remaining 10 data, we should impute the 10 data so that we cannot make all 10 as women. So if we make all 10 as women, then it would be 50-50, so then the distribution is affected. Okay, so that we can come up with 6-4, so that 50 to 56, 40 to 44, both have scaled up in a equal ratio. So while imputing, we should make sure that for regression or for classification terms or for regression for continuous variables, uh, the distribution shouldn't be affected. Okay, we're just getting some extra, we are imputing that feature so that distribution will not affected in that column alone. For the other column we will have anyway of the data, so that why we want to preserve the missing column is, see, even though one cell is missed, other cells value will have impact on the model, right? So this, instead of this one missing value, we cannot neglect the entire row, so that uh, we will kind of impute that one particular cell with some standard distribution value. Okay, using mean or median or repeated value, whatever it is, so that we can make use of other values. So the imputed value is not going to affect your performance of the model, it is same. Okay, next is exploratory data analysis. So it's a preliminary steps. So why do we need to do EDA? To summarize, okay, to understand the data better, okay, to uncover the relationship, to also extract the important variables. Okay, fine. So we have a lot of things. We have descriptive statistics, we have group by method, we have ANOVA, analysis of variance, we have correlation, okay, and causation, all sort of stuff. Okay, basic descriptive statistics, you can do pandas dot describe. It would give us the mean, median, min, max, values and all. Okay, and it also gives us the distribution, how the data is distributed, either left skewed or right skewed. This is an evenly distributed. You can see a center line with equal amount of data on both the halves. Okay, and min and maximum and equal amount of distance. But if you see this data, so here it is right skewed. You have more data in the second half of the data, and you have few outliers as well. Okay, so this case you can do descriptive statistics. And correlation statistics, scatter plot is for correlation, to find the correlation between dependent and independent variable. Okay, let's say price, engine size versus price, it is positively correlated. As the engine size increases, price is also increases. Okay, and again group by we can do certain things, right? And also or not encoding, pivot method, heat map, to get the correlations. Heat map, but again gives us correlations. Okay, so again correlation, what measure what extent different variables are interdependent. Okay, it gives us dependent as well. Okay, there is two things, one is correlation, again covariance. It also gives the uh, dependency, either positive or negative, and also gives us the magnitude, how much or how many. Okay, and for example, lung cancer is affected by smoking, and if it is raining, then you would be using umbrella. So all sort of things, right? And there is also another thing called causation. Causation is, this leads to that. Okay, so if you are smoking, it leads to lung cancer, then the smoking and lung cancer are correlated, and yet it causes lung cancer. But umbrella and rain are correlated but not caused. Okay, so if you have umbrella, it will not rain. Okay, uh, if you have rain, it is not mandatory that you should have an umbrella. But if rain is there, then umbrella is there, it's correlated, right? There is no causation. In spite of umbrella, there is no rain, and in spite of rain, there is no umbrella. But smoking and lungs or lung cancer are correlated. Okay, you can do all sort of things. You can do a correlation plot to find how data positive correlation, it's a negative correlation, and there is no correlation at all. Okay, if you see engine size and price, as the engine size increases, price increases. Okay, but highway mileage, as the mileage decreases, as the mileage decreases, the price decreases. Okay, you can see the difference. Sorry, as the mileage decreases, price increases, the negative correlation, because price high in the sense it might be a sports car. If it is a sports car, then the mileage must be pretty low, right? Because it's a high performance car. So that here it is negatively correlated. And here RPM and price are no correlated at all, because every car will have equal RPM. It's based upon the throttle and the range and all. Okay. And again, covariance as certain formulas like this. Okay, core variance and correlation measure between two variables, right? We also have Pearson's correlation. The correlation only gives whether they are dependent or not dependent, but Pearson correlation will give you the uh, correlation, positive or negative or neutral, but also used to measure the strength, how strong they are correlated. Okay, so we have all these methods. We will get into the code so that you will know them. Okay, fine. And we have these. So it would give us a correlation 0.81, positively correlated, and also gives us a p-value. So the magnitude. Okay, and finally you can do heat map with correlations. Okay, so this would give, wherever there is high correlation, it would give us darker color. Wherever there is low correlation, it would give a lighter color. Still it has negative and positive as well. So this blue color is negative correlated. So wherever there is dark blue, it is negative correlated. Wherever it is dark brown, it is positive correlated. In the mid, it is neutral. Okay, and ANOVA analysis of variance for different categorical variables. Okay, to find the variation of things and to find how they are different and all. So all these steps we will implement a code. Okay, so that you will get a better understanding, right? So again, to give a recap, build a model. Finally, model building. Finally, in the okay. The first thing is how to use heat map for attribute selections. Or yeah, we will implement that. Okay, after implement that, we will see. Because in heat map basically gives the correlation between variables. From that, we can find. See, even if it is positive correlated or negative correlated, it has impact on the output, so that we can use all those features for training the model, and we can neglect the rest of the model. Okay, so that way we can go. And building the model is again, it's a last step. First thing, you just build the model. Okay, next you evaluate the model based upon the evaluation metrics, regression or classification. Okay, and while choosing the right model, you go for cross validation and evaluation metrics, and then you use hyperparameter tuning. So once you have chosen the right model, and again this right the number of depth, you can choose the Gini or entropy gain to compute it. Let's say you use support vector machine, you can use the kernel, what kernel, it's a linear kernel or polynomial or radial kernel, and you can choose regularization term. So you have a lot of tunable parameters within a single model itself. Okay, in that case you can go for grid search, and again you have grid search cross validation to tune your model. And finally, model deployment. Okay, so let's move on to the code. Okay, so for the code we will be using Google Colab. I think most of you would have used Google Colab. I'll just give a small intro before, by the time it gets opens and gets connected. So it's a Jupyter notebook. So Python is an interpreter language. It doesn't compile. It has interactive capability. As you run lines, it gets executed and gives you the result. And you have IPython, interactive Python. So so interactive Python. So this Jupyter notebook is built on top of interactive Python. Okay, and it provides an web-based interface where you can write your code and get it executed, and you can have your text document as well. So it's for two-in-one option. Okay, and yeah. So first, let's start with the data analysis. Okay, data analysis with Python. I'll add a text block here. Okay, data analysis with Python. The first thing what we will do is we will try to import the data. So while importing the data, before importing data, we need necessary libraries. Okay, So I'll just copy paste things to speed up the process. Before that, you have to connect it. Okay. So only then it will be get connected to the backend server. This Google Colab is offered by Google. They provide a free server space, and you can get access to GPUs, TPUs, and all. You don't have to install Anaconda Python to set up your system. So you can use the cloud version. So now we are importing pandas and matplotlib. So pandas for importing the data and doing data manipulation, and matplotlib for plotting and analyzing the data. Okay, so now let's read data from the URL. Okay, so this URL has the data. It's a CSV file. Okay, so if you go to this URL, it would your CSV file will get downloaded. Uh, Sorry, I opened it. Okay, so it's a CSV file. It is just rows and columns and numbers. You can see you don't have a header. Okay, so in this case, you have to find the description to find what every column means. Sometimes the first row will be always a header row. So you can right away import it. But in this case, we have to mention what the header is. Okay. So here we have all these headers. So these are all the header types. Sorry, it's not a data block. It's a code block. So we have symboling, normalized loss. We have make, what make the car type is. We have fuel type, aspiration, number of doors, body style, drive wheels, engine location, front or rear wheelbase, so horsepower. So we have all sort of things regarding the car data set. Okay. So now let's read. Okay. Reading is we use, let's write it by ourselves. Okay. Very simple. Okay. We can use pd dot read. Okay. Once you give control space, this control space would give what are all the methods you having. Yes, I'm doing copy pasting because we have a lot of codes to cover. Okay. I'll share this notebook so that you can execute for yourself. Okay. Don't think Google Colab has autocomplete completion what I think into code. Okay. So once you do pd.read CSV, read from clipboard, read from Excel, read from JSON, HTML, you have a lot of method. Now we will read from CSV. Okay. So you can read from CSV, then you can pass in the file name. You can pass in the file name. Okay. And also you can give in the, sorry, the file name is a variable, right? You can give the file name, and you can give names. So all these things are headers. Okay. So you can either give columns uh, or else, okay, should I execute this? Okay. So now what you can do is you can just sneak peek into the data, using df.head. Once you do df.head, you can see the data is being converted into a column data frame. Okay, so you can get also, you can do df dot shape, so it would just give us the dimensions, like here, like 205 entries, 205 different new entries with 26 features. Okay, 26 feature columns. Okay, and you can see here the data is, so here normalized loss, so here we have certain question marks. So all these things are import, all these things are error values or missing values. So missing values, mostly it would be having nan type, NaN, which is not a number, stands for not a number. But here they have done this, put a question mark. So basically we have to convert all these question mark into a nan thing. Okay, so first thing, we have to first replace every question mark or else something with nan. Okay, so how we can do that? We can import numpy, because only numpy has nan. Okay, so we can do import numpy, and np.nan is what we need. Okay, so we are replacing every question marks with nan. Okay, so every question marks will be replaced with nan. So if you just wanted to know how this is distributed, then again you can use value counts and all. Okay, df of that particular value dot value counts. Okay, so but value counts is mostly done for categorical variable, but you can see question mark is 41 missing values are there. Okay, similarly even other columns might have these question marks. So that question mark you cannot replace or impute, it's pretty hard, because even question mark is a data. Considering that, we replace every question mark with a nan stands for not a number. Okay, and you can see all those things would be converted as a nan not a number format. Okay, so now what we can do is we can find the where we, like we can use the term is null. Okay, so there is a function called is null. So is null will give us the true or false for a particular column. So let's take normalized loss. Okay, this normalized loss we can do first. We'll do is null on entire data set. You can see this is false, this is false because it has value, but for all these things we are getting true because it is a null value. It is null is true for this, false for this. Okay, and also you can see the beautiful thing here. You can even sum. Okay, once you do the sum, uh, Python is very beautiful. It does type conversion, typecasting by itself. You can basically add up true, false, boolean values. Then all the true will be considered as 1, all the false will be considered as 0. You can see in normalized loss there are 41 missing values, and in as per number of dose there is 2 missing values, and bore and stroke there are 4 missing values, and horsepower there is only 2 missing values, and for price there is 4 values. So if you consider these things, okay, these are not fine, like minor missing value, then we can neglect these data points. Like we with from 205 data set, if you sum up everything, it is just 10 data. Okay, 10 or 15 data. Maybe if everything is correlated, it might be even 4 or 5. So you can uh, you can directly remove all these things. Okay, you don't have to impute the data. So if the data is not important, you can remove it. But you can see normalize this 41 data is missed. So here what we can do is we can remove the entire column. So here we remove the row. So if within this row, if any of these values is missed, we try to impute, or we will try to remove this entry. But if in a single column most of the data are not present, then we will try to remove the entire column itself. Okay, so for that function also, pandas has functions like drop na, and while dropping you can go for column wise or row wise. Okay, so what we can do is we have different techniques. Okay, so I'll just copy paste all those stuffs so that you'll know what to do. It's just a basic thing. So first thing is just in order to share. So normalized loss. So we have 41 missing data, number of those 2. These are all basic things. Okay. So how you can deal with missing data? There are 2 things how you can deal. Either you can drop the data, drop the row or drop the column, or else replace it with mean or more frequent value, this is median or mode, and replace it with based on other functions. Okay, based on the similar column you can remove it. Okay, so now here let's come to how to split them. Okay, you see this. Yeah, so here replace with mean. So we have all these things, we can replace it with mean. Okay, normalized loss, stroke, bore, horsepower, and peak, because all these things are some kind of continuous value, we can replace it with mean. Okay, but replace it with frequency, we can replace it with the frequency only, because let's say you have a 2 and 4. If you take a mean 2 to 4, then you will get a value for 3.5. So 3.5 door a car cannot have, because it's a categorical, right? In that case you go for frequency. So you use a frequency to do, then you majority is 4 doors, then you impute those data with 2, because 84 like out of 100 data, 84% is 4. 84% is 4 door, then again 86 is not big deal, right? So in that case you can go for replacing with frequency. So if it is in price column, so drop the whole row in price column. Why are telling like that? In the sense, see, we are trying to predict the price only. So if you try to impute the price value using some normalization or something else, basically it will be against the prediction. So our objective is to find the price, so that remove those 4 columns, train the model, then use the model to find the price for these 4 missing columns. Okay, so if the you don't have to impute the target column and all, you only have to impute the feature column. So target you don't have to impute, only the feature column. If it is continuous, go for mean and something like that. If it is categorical, go for frequency, like that. Okay, fine. And what we will do, we will first thing we will take the average. Okay, how do we take average? We can use these functions. Simple pandas data frame as simple technique. Average normalization loss, you can take the data frame of normalized and you can convert as type as float, because if you see the data frame dot d types, data frame dot d types, this will give different data types. So here normalized loss is an object. So even though it is a float value, it is considered as a string by the pandas. So it is not mistake by pandas, because everything is a string in Java or Python. We have to typecast to it so that only the type will be converted. Okay, so we are converting into float, and we are getting the average normalized loss. So this is 122. Okay, so this average normalized dot, we can replace it. Okay, so you go to this column. Okay, you take this column and you can do the replace. So this replace will take two arguments: replaced what with what. So replaced np dot nan with this average normalized loss. Okay, so you can compare like this. And if you run this, what will happen is it will return a new data frame. So in pandas, just remember, whatever the functions or operations you do, it returns a new data frame. It will not be applied to the original data frame. So in that case, what you have to do is you have to do in place equal to true. If you do in place is equal to true, it will be applied to the original data frame itself. So now you do df dot head. I misspelled head. Then you can see the initial three columns is filled with 122. So back then it is null. Now it has filled. But even if you fill this, the thing is we are not going. If you fill this by 122, it is not going to impact the model, because it is a distribution from the remaining data. Okay, but the thing is, if you impute this value, you can use the rest of the features. Those might be significant, right? The rest of the features to train the model. So that's the thing for imputation. Okay, don't think imputation is you're trying to fill it so that you can use it for training your model. It's not like in that case. You can use other columns to use it. Okay, so that's the main thing. So will f22 imputed as float or int? Of course it would be a float, but yeah, it's float only. Okay, let's see df dot d types. Yeah, so it's still an object. Okay, no, not normalized loss. Normalized loss, we have, sorry, uh, it's taken as a object only. So this you can change it. You can set it back as type, as you can set it back. Like basically you can do data of um, data of, let's use it, this data of this equal to data of this dot is type as float. So you can set it back. So we have not set it initially. So now if you check the d types, it will be of float 64. Okay, so now you can do the df dot head. Okay, so anyway, passing it to model this float. Okay, so initially we have not done this. Only doing this would convert the yeah data type of a particular column. But here we are just converted to float to get the average value. Now we took the average value and replaced the nan. But remember, this is float value, but this column's data type is string already, so that this float is typecasted to string. So that's still string, but now we have uh, taken up the data frame and converted it as a float type and reset to the original data frame. Now we are getting it as a float type. Okay, so that anyway, whatever you want, you can do. That's how pandas flexible. Okay, so now you wanted for other columns, you need to do the mean. Now you can do average. Okay, do for both column, you take as type average and you replace it with them. Okay, you can replace it with or average in place. Okay, so you can do all sort of things, right? And finally, for stroke, again the same method. For stroke, you take replace nan with stroke, find the average and replace. And for horsepower, take the mean or average, replace. Okay, and finally for this column, like for which column, again number of doors. For number of doors, you have to do we have left one more thing, horsepower. Okay, and also peak armors. We will transform that one as well, that we have not replaced it. Okay, so first thing is average horsepower. We can take average horsepower and put it here. and you can take peak RMS and put it here. Okay, so every column you are converting it. So this is replaced, this is replaced, and finally you have number of doors. So number of doors, you can go copy it and put it here. You do the value counts. Value counts is 4 doors 114, 2 doors 89. Only car can have 4 door or 2 door. The dicky is not considered here. 4 door or sports car 2 door, luxury car 2 door, and four doors in regular car. So now you can do is you can take the column, you can do the value counts, and you can get the IDX max. Okay, so this would give us the 4, which one is the maximum one. So you can use it to replace the nan. Okay, so now we are replacing the nan variable with the nan variable with the number of doors here. Okay, so you do replace with the 4 here. So either you can give this or you can mention 4 by yourself, right? And finally, if you see df dot is is null dot sum, sorry, is null dot sum. You can see every column has 0. All the values are imputed. Okay. Price is 4. We will remove the price column. Okay. Because price column is the target variable, you shouldn't impute that one. Okay. So drop in a price column, price row axis is 0. 0 is horizontal. If you give 1, the column will be removed. In that case, you have to give the price, entire price column will be removed. And reset index, why we are doing is in order to, we have dropped rows, so that's why we are doing the drop and reset index. Now we do the same stuffs. Okay, df dot is null, and you know we have everything perfectly. Okay, df dot head and thing. Okay, so that is how you handle missing values. Simple missing values. Sometimes complex, you can use last frequent values, like that is what we have done. You can use other models to impute the values as well. You can use linear regression and to do the stuff and all. And the second thing is correct data format. Now we have to correct the data format, because if you see the d types, df dot d types, this is float and make. So even though this number of doors is a integer column, it is still as a object one. So only if it is converted to integer, then we can able to apply certain statistical technique on top of it. Okay, so for that we need to convert everything to a string. So that is where the step 2 follows. Correct the data format. Okay, so d types we have seen. Now what we can do is we can take all these things. Bore and stroke has float type, normalized loss as integer type. Okay, and price as float type, and peak RPM as float type. So you can convert single column, or you can convert multiple columns. Similar thing what we have done earlier. So here we have just done only one column, typecasting. Okay, type conversion. So here you can do multiple column one shot, converting every data to a normal format. Okay, so now if you check df dot the types, we'll get all integer to integer, float to float. But make us Audi, Benz, BMW, it's object, fuel type, petrol or diesel, number of doors, and again number of doors still in thing, because number of stores doors still in object, because we have not mapped it to a number. It is 4 or 2. It is a categorical variable. It is not a continuous variable. So here we have 4 and 2 as a string, so that we keep it as same as like that. Okay, because it's a class, it's not a continuous variable of 1 door, 2 door, 3 door, or 4 door. It's 2 or 4 door like that, or 6 door. It's a van or bus or something like that. Okay, and now let's go for data transformation. Okay, so now we have seen certain types of data transformation, right? So why do we need to do data transformation? We'll add some here. So different data will have different ranges. Okay, data standardization will mean center your data. Okay, we take, and also it would all the data would be distributed around the mean. Okay, you can do normalization and you can do standardization. Okay, so let's say we have this thing, city and highways, miles per gallon. Okay, so first thing, we are just plainly transforming it. We are transforming it to miles per gallon to liters per kilometer. Okay, so that is one thing. Okay, we have to convert from a different uh, uh, unit measurement to a different thing. Okay, formula for is liters per kilometer is one liter liters per kilometer is 235 per miles per gallon. Okay, so like that. Okay, so we can do mathematical formula in pandas itself. Okay, so what we can do is we can convert it like this. We can add a new column. Okay, so which is city liters per 100 kilometer. Okay, so we can take numbers 235 and divide it by the number, this number. Okay, miles per gallon. Okay, so let's say if you do the head, uh, if you do the sorry if you just come down, if you do the df dot head. Okay, if you see the miles per gallon, where is it? Fuel type, not, it's not here. Okay, highways miles per gallon, so let's say it is 25, or else city miles per gallon is 21. Okay, so you take this number and divide it, 235 divided by 21. Okay, let's take it 20 and take it 200, then you get 10. So it is 10 10 liters per 100 kilometers in city scale. Okay, for converting the gallons to miles to city to kilometers kind of thing. So now we have converted. Now if you see this, you can see the numbers here. A new column is added. This way you can add new column to the data frame. Sorry if you're not familiar with pandas, this is how pandas works. Okay, um, we are adding a new column to it, and we are kind of using this column to get the value for this column. Okay, in kilometers per second, right? And remember, you have seen you can apply a mathematical operation on an entire column. So in pandas data frame, a single column is known as series. Okay, pandas two types of data things are there. One is data frame, the entire table, rows and columns, and next we have a series. Series is a single column. This series is similar to a numpy array. Okay, so what you can do is you can apply a mathematical operation or transformation one shot for an entire column. Okay, but the condition is true, because of course in numpy and panda series, in python list is a elements of any data type. You can have a string, integer, and anything on top of it. In that case, if you do a square, it would applicable to a integer number, it would be applicable to a float number, but it's not applicable for a string number. Okay, of course it's applicable in python context. You will get, if it is a, then you will get a, but you cannot square it. Okay, so but in series data frames and numpy array, it's typecasted, so every column or array can have a single data type. Okay, so whatever the operation you do it, it will be applied to the entire rows, so it is one shot implementation. Okay, so that way you can implement that. And the second thing is normalization. Okay, so why do you do the normalization? To scale them between the 0 to 1. Okay, so transforming variables with 0 to 1. Okay, so what you do is basically you take the maximum value, and let's say here we have df dot head. Okay, so here we have uh, length, width, and height. Okay, of the car. Okay, so length is 160 centimeters, I think 1.5 meter. Okay, I don't know what the unit it is. Okay, basically cars will be around 4 meter, 5 meter kind of range. Okay, so now what you can do is, we wanted to normalize it. So what you can do is you can take the maximum number of it. So length df of dot length, you can either use dot length or bracket of dot length. You can get the maximum values. Okay, you can use dot max, so this would return as a maximum value in that particular column. So as you said, you can apply in one shot, apply it to the normalization, apply it to everything, to the height, length, width, and height. So you get the maximum number and divide every number by that particular number. So now if you see the uh, values, how they are transformed. Okay, df dot head. So you can see everything is normalized, and you can see the percentage. Like you can see if the length is higher, and again with this also higher, and the height is also higher, because if the car is lengthy, then obviously all the dimension of the car will be higher, right? So, but if you see here, it is a huge number, and it is a middle number, and it is further smaller than. But in terms of variability or things, three values give the same thing. All the three are kind of same, on the range of 0.8. Okay, and you can see, you will not see much difference between different columns. Basically three things are correlated. Okay, length affect width, width affect height, both all things are correlated. Okay, and finally next will so this is how you can do the transformation, normalization. Okay. And code block 40. This code block 40 is, I've asked a question, what you have done in code block 40 is just got the maximum number. So maximum from that particular thing. Okay. So this is your data frame. You are extracting a single column. You can either use it like this or else use it like this dot notation is applicable for objects. So once you have an object, you can use dot to get the properties and methods of that particular object. Okay, so that way you are using that. So you can use this as well. Both would return the same result. So that's why you have confused, I think. Okay. So transformation, what transformation has have done? We have not done much of transformation. We have not encoded things, but we have done a little bit of normalization and standardization. Okay, next we will do binning and also we'll do encoding. So those are all two other methods. Okay. So why binning? Binning will convert the continuous variable to a categorical variable. Okay. So here you have binning. So here we have uh, how do we do it for if the series name has space? Series name as space in the sense you can do this. See, if a series name has space, it will not get affected. You can do it like this. If series name has space, you cannot use this. Okay. So cannot use if column name has space or it is a number. So this column name can be also be a number 0, 1 or 2 like that. Okay. In that case, you cannot do df dot 0 dot thing. So this you cannot use. Okay. So I will put it for reference. This you cannot use. In that case, you can use this. Can have space and numbers. You can do like this. You can do like 0 or 4. Okay, and anything should work. Okay, but this is not there. If you run this, you will get error. Okay. Oh my God. Even we don't have this column. Right. And binning. Okay, binning is transforming continuous to continuous to category variable. But if you see the horsepower, so here horsepower we have certain numbers, but based on the horsepower we can categorize them into a family car, a performance car, or it's a sports car, right? Because fine-tuned numbers will not make any sense, because if it is in a certain range, then it is a family car. There is a limit by the government. Okay, so if it is a road traffic car, then it has to have a certain horsepower and certain torque and pollution and stuff and all. So it is mostly a categorical variable, but yet we have a an integers. Okay, now we are trying to convert it as an integer. Okay, df dot head. Okay, so if you see horsepower, it is what is horsepower? It is a integer thing, but now we are trying to bin it. Okay, we can use binning. So binning, you can simply use plotting to do that. Okay, let's import matplotlib. Okay, let's import matplotlib as pyplot. Okay, and also what we can do is usually people will not import like this. What they do is dot plot from importer, like import matplotlib dot pyplot as plot. They would import like this, but the different notion that anything is fine. Okay, so now what you do is you take this particular column, okay, the horsepower column, and you do plot dot pyplot dot histogram. Okay, so this histogram you can pass in the bins as well, but this is a default bin. Okay, so here within 0 to 50 there's nothing. 50 to 80, 50 to 75 maybe, or 50 to 60, 60 to 70, 70 to 100, like that. So you will see most of the cars are in the range of this 50 to 150, and there are very less in more than 250, because most of them very less sports car. Okay, so you can bin it. So how you can bin it in the sense, basically you can create a thing called like this in the 4 different range. Okay, you can add this. You can take a minimum value and maximum value, and you can do a line space. So this line space would generate uh, generate numbers within a range. So within the minimum is 50, minimum is 48, maximum is 262, and you have created 4. So this would create 4 numbers within that range. If you give 10, it would create 10 numbers within that range. That is what line space does. Since we wanted to convert into 4 categories, now we are using binning is equal to 4, and group names is we are using low, medium, and high. Okay, so this is the group names we are going to use. So now what we can do is, if it is in range 48 to 119, it is low. 119 to 190, it is medium. 119 to 262, it is high. Okay, so what we can do is we can use this method. Okay. Df dot horsepower bin. Okay, we are trying to have a new column. Okay, this is horsepower column. We are trying to have a new column. In this new column, we are doing PD dot cut. So what it does is it takes in the horsepower. Okay, it takes in the horsepower data frame, and it also has the bins values, and we pass in the labels and include lowest. Okay, so lowest column you are including it. Okay, so once you do this process, what happens is you can write it much more simpler, but you can see all these things. Horsepower is, if you have this number, you get it low. If it is in this range, you will get it medium. You will have within a different range. Let's do tail. Okay, uh, tail will give last few values. Let's fine, let it be same. Okay, so we convert every uh, continuous variable into a categorical variable through this process. Okay, you don't have to do this cut and all. You can also do if else. If that it is greater than 48 and less than 119, then it is low. If it is within 109 to 190, you can give different mechanism. Okay, but the pandas uses one line easy function to do the pinning and all. Okay, and now if you do the plotting, okay, uh, for this particular thing, now you can see low is 150 cars in low horsepower, and one low horsepower is family cars. 42 like 40 cars in medium range, like Audi or the uh, road cars, but with still good horsepower and performance. And high is sports cars. Okay, high power. So you can do all those sort of stuffs, and also you can do basic visualization. We have seen all those stuffs, right? And also there's another thing is encoding. Okay, so you can convert the once after converting to categorical variables, you can convert into further numerical variables, because see, now we have done high, low, and all, but you cannot pass this high, medium, and low to the model. Again, you need to convert it to a numerical format. For that case, we use one-hot encoding. Okay, one-hot encoding is, let's say we have 3 categories. Okay, it will be like low and medium, okay, and high. So if some car is having low, then the value will be 0 comma value will be 1 comma 0 comma 0. If it is an high, then it will be 0 comma 0 comma 1. So this is one hot encoding. Okay, so this is one hot encoding, right? So basically you can do these stuffs, right? So for this pandas as a simple method, what you can do is you can use get dummies. So dummy variable pd dot get dummies, because why we are doing get dummies in the sense, let's take df dot head. In this case, you cannot integer encode. You can integer encode for output variable. Let's say your car is let's say will you get a job or not. In that case, you can integer encode. If it is no, then it is 0. If it is yes, that is 1. For output feature, output target variable, you can integer encode. But let's say for fuel, if you are integer encoding, you convert uh, gas. Where is fuel type? Fuel type is here. Okay, fuel type is mostly it will be petrol or gas. Okay, gas or diesel, whatever it is. So here, if you do the conversion, okay, what will happen is gas will have 0 and diesel will have 1. So the value with 0 will have no impact at all, because it is completely zeroed. Okay, when you multiply it with something, you will not that value will not have any impact. So that we are going for one not encoding. Okay, or else you can simply integer encoding. If you have more value for making it all, you can integer encode. If it is Alfa Romeo, then it is 0. Audi means 1. Benz means 2. Honda means 3. You can kind of integer encode. So that's why we are going for dummy variable. Once you do this, you can see this diesel and gas, kind of a new 2 column is added. In this new 2 column, if it is a gas type, this gas column will have value 1. If it is of diesel type, this diesel column will have value 1. Okay, So this function, we are doing this operation. Okay. So we are doing everything in one place. Okay. Finally, we do conversion and concat it. Okay. So once again, we have done the conversion. Okay. Now we have renamed the column, and finally we merge it with the original data frame. Okay. Fine. So now you drop the fuel type because fuel type is not needed. So now if you do check the data frame dot head, the fuel type, instead of fuel type, fuel type is not there, but we have added two new columns. One is diesel and gas. So wherever there is diesel, you will get one. Wherever there is gas, you will get one here. Okay. So in two columns, you will get two different values, right? And the same dummy variable you can use for aspiration as well. So where is aspiration? So for aspiration, you will have like standard or something like that. Okay. You can get df dot aspiration dot value counts. Okay. So this aspiration as standard is 165 and turbo is 160. Okay. In that case, you can convert them into 1 not encoded. So likewise, you can write the code like this. Aspiration get dummy, set it and rename it to standard aspiration standard and aspiration turbo. You can rename it like this. Okay. Now if we check df dot head, so this aspiration column will have new columns for this values. Okay. Fine. And what else we have? Yeah, so finally what you can do, this is cleaned data. Now we have imported the data, cleaned the data, removed all the missing values, imputed whatever we can, and removed the price column. We have done feature transformation, we have done normalization for height, width and all, we have done standardization for other columns. Now we have done feature transformation as well, continuous to categorical using the binning process, and continuous to integer using the 1 not encoding process. Okay, so you have done all sort of stuff, and finally you can export it to a new CSV. So this CSV, if you see here, this will have a new file, which is a cleaned data. Okay, this data will be cleaned. You can use this data for modeling. Okay, so I'm getting a lot of questions. We will, in place of fuel attribute, we replace it with 1 not encoding, which means one column becomes two column. Yeah, one column becomes two column. One column can become two or more column. So because here we only have two categories, it has become two columns. Let's say we have standard, turbo and super turbo, then it would be three columns. So there will be three columns. Wherever it belongs, there it will be one. The remaining column, it will be zero. Likewise here. Okay. So we will have very less time. We will quickly move on to the exploratory data analysis. That is very important. Okay. So we will create a new notebook. Sorry if I'm rushing. Um, problem, I think. Anyway, you will have all these resources later the session. You can go and play with them anytime. Okay. ATAL FTP. Okay. FTP. Ramakrishna Mission Vidyalaya. Now we have EDA. Okay. So why do you need to EDA? EDA involves a lot of steps. Mainly is plotting. Through plotting, we can get a lot of insights from the data. Okay. So the first thing, first we will import the libraries. I will just cover most important part and all. I think even if I take extra 5 to 10 minutes, no problem with that, because we have 1.5 hours break that I can take till 1:30, 1:15 like that. Okay, don't worry, I will not extend up to 1:30. 1:10 would be sufficient for me. So again, we are taking in automobile data. Okay, but this automobile data is already cleaned. Okay, cleaned in the sense you can see df dot is null. Okay, dot sum. Okay, so you can see. Okay, stroke is not there. Okay, so basically you would be importing data, this data, only this data we are supposed to import because it is cleaned data. Okay, but you can see the diesel and gas column added. Okay, and there are few null values. We will remove that anyway. Okay, so now let's use Seaborn. Seaborn, this inline plot is only used for Jupyter Notebook. It's not needed for Google Colab. Colab can do these things. And now we have d types. Okay, simple things, same stuff. D types to find what column it is. You can see, okay, everything is not in format what we expect. Okay, so for that what we can do is we can convert them. Okay, before converting them, let's go for the correlation map. Okay, the correlation map is, you can right away use the df dot corr correlation. So this would give us a table written as a data table. You can see from the same variable, symboling to symbol, it is 1 because both are same, it is positive correlated. Okay, but you can see, let's consider length of the vehicle to the price of the vehicle. So length is here and price is here, so it is 0.69, which is 70 percentage. So 70 percentage they are correlated. Okay, length affects the price, right? Because if it's a lengthy car, then it more price it would be. And horsepower, is again, where is the price, again affects the price 80 percentage. Okay, and if we see mileage, city mileage per gallon, it affects the price, but you can see it is minus zero point 0.6, because if it is a, if fuel is, if the fuel mileage is low, then it is a sports car. Okay, it might be a crap car, but again most of the time it is a new car, then it might be a sports car. So again, it correlation is there. It affects the output of the price, but in a negative manner. If the mileage decreases, price increases. Okay, and you can see city liters per kilometer, and again if it increases, it gets increases because it is direct correlation. Okay, we have converted it, right? So when you get more mileage, then it's for city limit how we are driving. For gas and diesel, there is no much correlation. You can see 0.1, it is subtle, slight correlation. So if you get -1, it is full negative correlation. If you get +1, it is full positive correlation. If you get 0, it is neutral correlation. And any number in between will have slight impact. Okay, so that what we can do is, okay, price, symboling as no correlation, normalized loss no, wheelbase as a correlation, length as a correlation, width as correlation, height doesn't have a correlation, because height almost every car will have a same height only, because car is the level is there, and curb weight same, positive correlation, engine size positive correlation, and you can say get certain things is negative correlated. So these are all just numbers. We can also get them as a beautiful visualization. Okay, so let's compare four things and do the correlation for it. You can also get sub features and you can get the correlation like this. Okay, so how bore, stroke, compression ratio, and horsepower are correlated, or else how height, width are correlated. Okay, so let's use height, uh, width, and we'll remove this. Okay, length. Okay, so how these things are correlated. You can see there is a correlation between width and height, width and length. Okay, you can see these numbers. Width and length are highly correlated. Again, width and length are highly correlated, but width to height and height to width are less correlated. We can see this less correlation here. Okay, so you can also plot in a mm, so in one question, in reality, will engine weight affect the price? Yes, it might do, because if you are having a sports car, in sports car engine will be behind. Like let's take Ferrari, Aston Martin, or Bugatti, engine will be behind. Family cars engine will be in the front, and engine will have more components. It will be weight, of course, it will be weight, and also it used for stability purpose as well. Okay, yeah, now let's do some numerical analysis, continuous numerical analysis. Okay, so first thing we have, we need to compare between the price and the engine size. Okay, so engine size versus price. Yeah, yeah, ma'am asked that question, Kiran asked that question, but again we got it on the code itself. You can see there is a positive correlation. Okay, so as the engine size increases, price increases, because it is a good car. Because in Maruti 800 you will have a motorbike car only. You can see very tiny engine. It's just 300 500 cc or 800 cc. It can pull out the nano car and all. Okay, but if your engine is having 2000 3000 cc, then it is a huge engine. And again, the pricing is also will be same. Okay, so simple correlation map. For this to implement in matplot, you have to write a lot of lines, but C1 made it simple. Just do regression plot, and you can also see whether the value falls within the central regression line or outside of the scope and all. Okay, so and again you can also have other correlation. You can see the correlation, engine size to price correlation, it's 87 percentage. And highway miles per hour to price, it is negative correlation. Okay, so it is in reverse. Okay, negative correlation. And Uh, yeah, can you please comment on the impact of correlation on dimensional reduction? Yeah, dimensional reduction. See, if height and width and length are correlated, both are correlated, you don't need two feature. You can use only the width alone, or else length, high length alone. Okay, but that is not how dimensional reduction works. Dimensional reduction, what it does is, it takes 10 or 20 features and it projects to a plane where correlated features falls on the same plane, so that you will get a new feature where these two will combine and you will get a predominant feature. Okay, it's not about reducing the features. Okay, you will get some new features, the predominant features. Sometimes you will get the which features have more impact, you will get a new columns. And again, correlation have impact. So in this case, if you reduce the dimension, maybe you can reduce all three to one. Basically, length, width and height basically tells about the dimension of the car, right? All about size. So all these things are correlated, we can make it one. Okay, so that has an impact on dimensional reduction. So if you are doing PCA, then you I will able to show that, but we are not doing PCA. PCA is on day 4, I think, and I will not be there for PCA as well. Okay, uh, that's okay. And yeah, highway and price negatively correlated. Okay, and if you see peak RPM, RPM is rotation of the thing, right? Okay, then there is no big difference, because rotation doesn't define how fast or the price the car is going. It's all about performance and all, right? Okay, so it's neutral correlated, so there is no correlation at all. If you do this correlation map for this one, you can see it is a negative value. So here we get the value magnitude as well, like it's minus zero point 0.1. It's neutral. Okay, and you can also do for stroke versus price, and again, stroke is 0.08 percentage. Again, doesn't have any impact. What stroke, full stroke or half stroke, two stroke or four stroke, whatever it is. Again, if you plot it, you will get the same thing. Okay, stroke versus no correlation, right? And categorical variables. So let's have categorical variables, and let's do some analysis on categorical variables. Okay, so let's take categorical variables. Okay, these are all small set of variables, and we can use it to do some plotting and all. Okay, let's take body size, body style to price. Okay, body style to price. How you can find the correlation? You can go with box plot. So if it is a convertible, so the minimum price is 15K, the maximum price is 30K, because it is a car, like car where it can as an open rooftop. Okay, it can open the roof, so that it's a convertible car. But hatchback, mini car, Swift, Polo, and Maruti 800, all these hatchback, you can see the minimum price is about 8,000 and maximum is 10K. Okay, around 10 to 12K. And sedan type and all. But hard top, you can see it is maximum. Hard top is mostly it will be an SUV, because SUV like Thar and Range Rover and all. So you will have a hot top, so that price. So this is how these categorical variable affect the price. And also you can have fuel type. Again, I think fuel type we have converted it. What else the categorical variable we have? We have engine location. Okay, engine location is behind or front. There are two type of engine location: front and rear. Rear means sports car, always more than 35K. If it is front engine car, it's normal car. There are some outliers, because in even in that cars we have still have Benz S class and all, C class and all. But again, that's different thing. I'm fond of cars, that's why I'm telling these things in detail, right? And again, we have drive wheels. Okay, drive wheels: rear wheel drive, front wheel drive, and four wheel drive. All wheel drive. Okay, all wheel drive, it will be an off-road vehicle. Front wheel drive, okay, it's very less cost. Okay, that is what most of the cars will. But rear wheel drive, it's much more complex. You need a differential to rotate the tires and all. Okay, in that case, you go for all these things. Most costly sports car. And let's go to the discrete statistics. Okay, last one. Without title only, content will not make any sense. Okay. Uh, Okay, descriptive statistics. Okay, so why you can get the minimum, mean, max, minimum, average. You can also get the distribution, standard deviation, all sort of stuffs you can get. So in pandas you have basic dot describe. So this describe is actually gives us a box plot with all those count. So it will be only applicable for columns like integer and float. Of course you can include object columns, but mostly applicable for integer and float columns. Okay, so you can see in length, maximum length, the count is 201 data is there. You can see the mean length is 83, maximum length is 1 because we have normalized it, but that's neglected. But engine size, uh, mean is this, maximum is 326, and minimum is 61. We just take it CC. CC is 1000 CC. It's not engine size is different. Okay, it's something different to that. Okay, and we get the standard and within the range 50% and all. Okay, so basically it gives us a basic analysis of how the data is distributed. Okay, and even you can do a violin plot with these things. Okay, uh, violin plot. Okay, if you go this violin plot also gives us the distribution and also gives us the thing. Okay, let's take we are doing distribution same. This would give minimum value. Okay, so you can see this is the box plot, is what this thing is giving. So count, minimum, standard deviation, min, max, and percentage. Okay, mean is here, and this is around the distribution. 70% of the data falls within this region, then it is a uniform distribution. Okay, and this is the maximum value, this is the minimum value. And again you can convert the same thing to but here there is no visualized way for the distribution graph, but violin plot can do that as well. So if you see the age versus the social media, and again male female, here we have three features plotted in one single graph. Instagram, uh, if they are male, then it is above 20 only using, but if you're female, even teenagers are using the Instagram too much. But if it is Facebook, male, it is above 40 maximum usage. For women it is equal distribution. For Twitter, men around 40. For female it is early and the later stages. Okay, so this distribution gives us how data is distributed, either left skewed or right skewed or uniformly distributed, all sort of stuff. Okay, and yeah, so we can get some valley counts to know how many numbers are there. We can also convert valley counts to frames. Okay, and what else we have? Okay, let's repeat the same thing here what we are doing. Okay, so here we are trying to wheel drive counts. Okay, so this like how many different numbers, like different methods to do that. Okay, and finally engine location we can also get for engine location. Engine location, valley counts dot to frame, front and rear, same thing you will get. And again basic grouping. So grouping will would be you can have a variable, based on that you can group it and you can analyze it. Okay, so it is basic grouping. Okay, we'll try to add it here. I'll take 5 more minutes, please bear with me. We'll finish up by 1:05 or 1:10, not more than that. Okay, so group by what you can do is you can group based on different features. Okay, let's say you wanted to group by drive wheels. Okay, so in that case you can group them like this. Okay, group by drive wheels, and okay, group one is not there. Okay, group one we have to create there. Okay, let's take drive wheel. So in drive wheels we have three classes. Okay, three types: rear wheel drive, front wheel drive, and four wheel drive. And we are doing group one. So this is the initial method, like what are all the methods and price. And now you can group by the drive wheel. You group by drive wheels, you are taking the mean. So the mean, uh, if you remove mean, what will happen is you will get a map like this, or it will get a data frame. If you print it, okay, not print it. Okay, so if you give mean, what will happen is all the values and the numbers would get added up. Okay, and you will get a total mean for all the different types. Okay, so basically applying statistical techniques based on groups. Okay, that's what it does. Okay, I'm not getting group by. I think I've already done it once again. I'll do it one more time. Group one, group one, group one. Okay, yeah, that's what basically we do, right? Fine. And finally, for other wheels also, you can do the group by results. You can group by drive wheels and body style and price. And still you can see if it is a four-wheel drive, if it is a hatchback, then you would get this price. If it is a four-wheel drive, then it is a sedan type, then you would get this price. Okay. Again, four-wheel drive wagon, then it is 9,000. So based on different combinations of groups, you can get the statistics average price. Okay, you are getting average price. Okay, average price for it. So all these tricks are related to pandas. So once you have mastered pandas, you will be able to do all sort of stuff, right? And also you can able to do the pivot plot. So this pivot plot is would gives you the rows and columns. Okay, so it's much more efficient than this visualization. So here you have body style on top and drive wheels here, and also price. Okay, price is the value. So there is no four-wheel drive convertible and hardtop. Okay, but there is four-wheel drive hatchback, sedan and wagon. Why it is in inverse? Four-wheel drive mostly it would be a hardtop, something like that, but I don't know what hardtop is. I thought it is a off-road vehicle. And front wheel drive we have all these range, and rear wheel drive we have all these range. Okay, so and again you can do a lot of group by stuffs and all. Okay, finally we will move on to the correlation heat maps. Okay, so now let's import the plot library, and now we are group pivot plot. So we take the group pivot plot, already pivot plot is there, and we plot it. Okay, so we try to plot it in a colored manner. So now you color it. You can see the low is this dark. So this is the low. So this is not that visually appealing. Okay. But this is visually you can see, okay, where it is low, then you can correctly go into this quadrant and you can easily find it. So here it is null. That's why it's white, pure white. Okay. So here it is slightly faded. If it is high pricey, then it can go for this green. Okay. So convertible hardtop with rear wheel drive, it is that much cost. If it is a real wheel, then engine is in the back side, then it's a sports car. Okay. And also you can plot multiple maps. I'll not get into the map functions and all. I'll just show you the plot. Okay. You can get convertible hard tops and all. Okay. For this, you need to master plotting library and pandas library. Okay. And we'll come to heat map. Okay, we'll come to heat map. We will come to correlation and causation. Okay, so next is correlation and causation. So this is just to compare the stuffs, but this is correlation causation. So measure of extent of interdependence between variable, relationship between the cause and effect of two variables. So those two things we can get it. So this Pearson Pearson correlation, that is what we are trying to get. Okay, this Pearson correlation is one is positive linear correlation, zero is no correlation, minus one is negative correlation, right? And again, we can use it with simple df dot correlation, but also we can do the plotting. So now let's do the plotting, and also we get a p-value. We can see how p-value will affect, because Pearson correlation gives us both the correlation and also the strength, like how strong it is, how strong the significance. Like p-value is less, then it is strong. If the p-value is more, then it is the less evidence of correlation is there. Okay, so in this way you can see even if they are correlated, whether it is there's a strong significance or not, you can map it like that. Okay, we will import the stats module, and we will calculate the correlation. So Pearson coefficient, p-value, we can calculate stats dot Pearson's correlation, and you can pass into variable like wheelbase to price. Okay, so wheelbase to price, whether they are correlated or not. It's 0.5 correlated and p-value is 0.8. Okay, it is more. And it's not 0.8, it is -2, it is 0.00008, so that it is significant. Okay, because wheelbase do affect the price, it is more significant. Okay, it is less than 0.001. Okay? But let's take horsepower and uh, thing, and horsepower one thing also, it is positively correlated. Okay, and you have 0.000063, which is strong correlation. But let's take something like what we have seen, curb weight, right? Curb weight, or engine size, no engine size, bore. Okay, this bore price, if you take, not bore price, we'll take a new one, highway miles per gallon. let's take this one. Okay, if you take this one, it is 0.5, and here it is only 8.049 percentage, and it is just minus 17. So e to the power of minus 17. Let's see where it is less correlated. Price is 0.8. Look, symboling. Okay, let's take symboling and try for that. Okay, and symboling. Let's do symboling. So here you can see negatively correlated, and also there is no strong significant. Okay, because it is not less than 0.1, it is between the range of 0.1. So there is weak evidence that the correlation is significant. Okay, so we'll be using the positive and negative correlation. Both can be used for modeling, and also we will be using significance. So based on the significance, we can go for choosing the features. Okay, uh, okay, so based on the significance, we can go for features. And finally, where is the correlation heat map? I think correlation heat map. Once again, I'll check the where the code is. Yeah, I think the code is not there. Again, you can plot this. Let's see how we can plot this. This is a simple plot. Okay, so by afternoon, I will try to plot this. Again, you will get a beautiful colored version of thing. Okay. Okay, once again, we'll search online to get the code. Let's see where luck favors or not. Data frame correlation heat map. Go to Stack Overflow, copy everything, and go and where is it? Where is it? Here it is. Okay, so here it is. Paste here. Okay. We don't have data. We don't have all these stuffs. Okay, we only have to find the correlation for a data frame. Df dot correlation. Sorry, what that's not df. Yeah, df dot correlation only. But why we are getting the error? Pandas dot or there is no model called pandas. We don't need that. Yeah, super color, right? So here you can see there is wherever there is a strong correlation, you will have light colors. Basically, diagonal will be light color because it is direct to the same variable. And you can see these length, width, and height are correlated. And again, around here it is again city miles per hour and city miles per hour and highways miles per gallon, both same. And you can see how horsepower is affecting the price. Okay, so you can see the color here. And wherever there is no correlation, you will get this pinkish color, violet pinkish color. So all these things are not correlated. Peak rpm, we have seen the numbers, right? Peak rpm has no impact, also like no effect on the output, right? In that case, we can neglect the peak correlation values. You can get correlation values are here. In order to plot correlation values inside the plot, that is what we are asking about. We can filter the attribute based on correlation value. Yeah, yes, you can do that. You can plot in any style you can want. If you want like this, you can do this. And well, will it work or not? Let's try. Who cares? Yeah, super. Okay, so we're getting a map like this. 4 to magnify. Okay, so Stack Overflow and Google is always to save us. You can get the values and plots and code, but you should know what to do and how to do, right? So I think we have got enough covered with data transformation and exploit data analysis. And like now we have understood the data. Like now let's say, okay, what features affect the price? Let's take the price column, wheelbase, length, width. Okay, height is not that much. Curb weight and engine size, bore. Okay, and horsepower and city liters per 100 km. Okay, all these things affect. So all these blue columns, we can take it and use it for our modeling. And also you can see these things are negative, all these red columns. So all these dark blue and dark red columns, we can use it for modeling. If you use other columns, there is no use. Okay, so yeah, so again you can fetch these columns, and you can further do a dimensionality reduction. Then you can convert. Let's say there are 15 columns here. You have converted, you have fetched up 1 2 3 4 5 6 7 8 9 and 10. You have taken up 10 columns, and within this 10 columns also you can further do the dimensionality reduction and get 5 or 4 features. Okay, and based on that you can build your models. Okay, and yeah, that's all. That's pretty much what you need to understand. and analyze the data because when you have more columns, you will not know what features to select while training your model. So this is one of the important step. You can manually choose, like you can create a sub data frame, df of height. There is an automatic way to do that. Height, width, and all sort of things. You can create a sub data frame with all those 10 features, and you can create a new data frame out of it and use it to model your model machine learning algorithm. Okay. I think that's it for this. Any doubts, you can drop it in the chat box. I think I have answered most of the questions as we go along the session. How you can use TensorBoard from Colab for plotting? TensorBoard is pretty simple. Uh, uh, TensorBoard on Google Colab. If you go here, Google Colab itself has a beautiful example, but it's mostly suitable while training. You can inspect training while training a neural network model, and also it's used for interpret as well. But if you see the funny reason, actually TensorBoard was developed to debug a TensorFlow model, because TensorFlow model is not debuggable in that version 1. Okay, because it uses the static dynamic graph pattern, but now it has made a dynamic static graph pattern. Now it has done dynamic graph. But okay, of course you can have some variables, and you can import the TensorBoard, and you can pass the variables to train it. But mostly for model training, you can find it. So I think it's dynamic, right? Why it is not working? You can click and change all these things dynamically. Maybe I should run the notebook. I think once you connect it, you can be able to do all sort of stuffs. But TensorBoard mostly used for deep learning. Machine learning will not be needing that much. Okay, fine. With that, we will break for lunch, and we will get back by 2:30. And for 2:30, we will discuss on the uh, building the model, tuning the model, hyperparameter tuning, and choosing the right model, evaluation metrics, how you can evaluate all those models, and we will compare different models, and we will take a live data and we'll try to implement a solution for that. Okay, and thank you. See you by 2:30.